The linear correlation coefficient is R equals 0.354. And N is 35. N is the number of pairs of data I have, XY pairs. It says determine the critical values of R and state whether a significant linear correlation exists or not. And we're going to use a significance level of 0.05 or 5%. All right, so we're going to find this critical values. We can use a table. You need to be able to look up a table. We can get the critical values. This is a table from a statistics book. It says critical values of the Pearson correlation coefficient R. It has 3 columns. We have an N as the first column. That's the number of pairs of data. I have 35 pairs of data. And then it has 2 columns for 2 separate significance levels. We have a significance level of 0.05, which matches with the middle column here. So I'm going to go down to 35 and over to the right to get 0.335. So the critical values, all right, so I'm going to say using a table, get the critical values here. They come in opposite pairs. So on there it read 0.335, so the critical values are plus or minus that. All right, so that's the answer to the first question. It says determine the critical values of R. The next thing it wants is to determine whether a significant linear correlation exists. And what we're going to do is we're going to take the R value and test it against the critical values. You can think of a number line. We have the critical values, negative 0.335 and 0.335. This separates the number line into 3 regions. So we're going to take the R up there and determine which region it's in. If it's in the outer regions here, it is a significant linear correlation. If it's in the middle region, it is not a significant linear correlation. All right, so we take the R value, it's 0.354, which is a little bit above this critical value. So it's in the upper region there. It's in the significant region. Here's the R right here, 0.354. So since R is above the critical value, then we're going to say that there is a significant linear correlation. There is a significant linear correlation.